Good morning, Algebra 2. I want to talk about roots and zeros. And I did a lot of writing first, but I'll post these notes so you can see them. I didn't want to spend forever writing on a video. Okay, so the concept summary talks about the vocabulary, zeros, factors, roots, and intercepts. And if you remember back from Algebra 1, these are all kind of related. They're all kind of summaries. If I have a function, p of x is x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12. And I know that the zeros are at -3, -2, 1, and 2. Those are also my roots. Zeros and roots, they're the same kind of thing. Okay? They go along with my factors. Now remember that factor form is x minus r. R was for root, you know. Okay? But it also goes for zeros. So when I have my factor form of x minus r, that means that my factors would be x plus 3, x plus 2, x minus 1, and x minus 2. Okay? Because that r, that's our factor form, x minus whatever the root is. Okay? My x-intercepts, when they are real numbers, I can write them as ordered pairs. Okay? But that's where you'd look for them on your x-axis. Now, in your book, it says, since real numbers and imaginary numbers both belong to the set of complex numbers, all polynomial equations with a degree greater than 0 will have at least one root in the set of complex numbers. Now, what does that mean? Okay? Well, just pick it apart. Real numbers and imaginary numbers. I get real roots and imaginary roots, okay? We already know that. Sometimes we get those i's. Remember when we had to do the quadratic formula and I had to go back and give you some more because there weren't any, all the multiples of 3 didn't have i's in them. Okay, so it's that idea that a plus bi is a complex number, but it's got a real part and it's got an imaginary part, okay? So, real, imaginary, complex. They kind of go together. All right. So, determining the number and types of roots. Okay. So, x squared plus 6x. These are the examples in the book. X squared plus 6x plus 9 equals 0. Now, you should know that x squared plus 6x plus 9 is a perfect square trinomial. And when you factor it, this 2 means that x plus 3 is used as a factor twice, so it's a double root, okay? If you wrote it out as 2 factors, you would have 2 roots, but they'd both be the same. So we just solve it by doing square roots. X plus 3 equals 0, so x equals -3. -3 is your root, okay? And it's a double root, so it's a repeated root. It's really the same root used twice, okay? It has 2 roots, it's repeated. And that's that idea, it's repeated. It's a double root, okay? You'll see some of these. If you look at a graph, okay, and you say, wait a minute, why is that number twice? Because it's repeated, okay? When you factor example B, you pull out that greatest common factor of x, and you get x squared plus 25 equals 0. So either x equals 0 or x squared plus 25 equals 0. This is one root, okay? When I solve this, most of you, just because you do x squared equals -25. These are your imaginary roots, okay? And you get that x equals plus or minus 5i. So because of this plus or minus, that means I've got 5i and -5i. Okay, so I've got 1 real root and 2 imaginary. Okay, 3 roots in all. 1 real, 1 imaginary. Okay, guided practice. 1a is very similar to example B, where I'm going to pull out that common factor of x. So either x equals 0 or x squared plus 2 equals 0. This is my real root. Okay? And then when I solve this, remember when you do a square root that you have to pull out that I, okay? So I have one real root and two imaginary roots. Okay? X squared minus 16, that's just a difference of squares. Did I copy that right? Oops, that's x to the 4th power, which is still a difference of squares. But that gives me x squared plus 4 times x squared minus 4. And this, you remember, breaks down. So I have x squared plus 4 as a factor, and x plus 2, x minus 2. This part gives me x equals negative 2 and 2, and these are my real roots. Okay? When I solve this, okay, so I've got 2 real roots and 2 imaginary roots. Okay? So remember, we talked about this one. How do you factor this one? Because you can't factor by grouping. It doesn't work. Okay? But you know that your first term is a product and your last term is a product. So I know the factors of 10 are 1, 2, 5, and 10. And so I know that chances, now it's a minus 10, so I could have a positive or a negative. So I kind of do guess and check. And that's, you know, we learned synthetic division. It's really easy and it doesn't take much time. So I would check either 1 or negative 1. Okay? So if I check 1, and I've got my coefficients, 1, 4, negative 7, negative 10. Okay, 1 times 1 is 1. That gives me 5. That gives me negative 2. That gives me negative 2. That gives me a remainder. That's not going to work. If I try negative 1, that gives me 3. That gives me negative 10. That gives me positive 10. That gives me no remainder. Okay? So that means my depressed polynomial is x squared plus 3x minus 10, which you should be able to factor. This tells me the signs are different. And my other two factors would be, I'm going to have 1 plus, 1 minus. Factors of 10 with a difference of 3. It's more positive. Okay? Now, that minus 1, remember, when we turn it into a factor, it would be x plus 1. So my roots are negative 1, negative 5, and 2. Now, could I have done that on my calculator? Yes, absolutely. And I would let you, okay? Because you know how to do synthetic division, and we are going to have to do those depressed polynomials to find our imaginary roots when we have these larger exponents, okay? Now, what you have to recognize, and you're going to love this corollary, a polynomial of degree n has exactly n roots, okay? So the degree tells you the number of roots you need. So when I had a third degree, I needed 3 roots, okay? And that just kind of makes a lot of sense because I've been telling you that since you were in Algebra 1. The degree tells you the number of roots. That's why you've got to recognize that some of them have that double root, okay? All right, Descartes' rule of signs, okay? And he just says you're looking for the number of sign change, not number of sign changes. So when I look at here, positive to positive is not a change. Positive to negative is, okay, so that's a change. Negative to negative is not a change, but negative to positive is, and positive to negative is, and negative to positive is. So there are 4 sign changes. That means that there are either 4 roots, or it goes down by 2s, 2 roots, or 0 positive roots, okay? So, and these are just the possibilities. We're not graphing, we're just counting, okay? Now, if I had f of negative x, this is an even power, so it's going to be positive. This, because it's an odd power, is going to make it negative. This is an even power, so it's going to stay negative. Okay? This is an odd power. Negative times a negative gives you a positive. This is going to stay positive. This is going to become positive. Okay, so if I look at my sign changes, positive to negative, that's negative. Negative to positive is a change. And then all the rest are positive. So the number of sign changes are 2. So that means that I either have 2 or 0 negative roots. Now it has to add up to 6. So I have to think of the possibilities. Can I have imaginary roots too? Yeah, okay. So that's what that was talking about in the table, the possibility. So let's look at the guided practice. H of x is 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. It's a 5th degree. I know there has to be at least 1 real root. Do you remember why? End behaviors. Go opposite direction. It's going to cross the x-axis somewhere. Okay, so sign changes. Positive, 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 negative, negative, positive. So there are 2 sign changes. So that means that there are either 2 or there are 0 positive real roots. Okay? Now when I do the opposite of x, okay, then that means this is a 5th power, so this is negative 2x to the 5th. This will be positive. This is going to, an odd power, so that'll be negative. This is an even, so it's going to stay negative. Negative, negative becomes positive, and then my plus 9. Okay? So negative to positive, that's 1. Positive to negative, that's 2. Negative, negative to positive, that's 3. So my number of negative roots is either 3 or 1. Okay? And again, it's that idea that I have to have at least 1 real root. Okay, so what about imaginary roots? So if I look at my positive roots, okay, I could have 2. Now I could have 3, which means I wouldn't have any because 2 plus 3 is 5. It has to add up to 5, okay? If I had 2 and 1 of these, because it could be this or this, then I'd have to have 2 imaginary, because remember, it has to add up to 5, okay? If I had, now I've done all the ways I can with 2 positives, so what if I had no positive? Well, I only have a possibility of 3, so that would give me 2, because again, it has to add up to 5, all right? If I had 1 of these, then that means I could have 4 of these, because it has to add up to 5. I have to have 1, so I'm not even going to look at 0, 0, because it has to have 1 real root. Okay? So that means I could have 2 or 0 positive roots, 3 or 1 negative root, and if I look at here, imaginary roots, okay, I could have 4, 2, or 0, okay? So we're just looking for the numbers. What it could be, not necessarily what it is. Okay. In example 3, they give you this polynomial, and we're going to use synthetic substitution to find zeros, but we're going to use synthetic substitution to find the imaginary zeros. We're going to use the calculator to find the real zeros, okay, and use synthetic division to get our depressed polynomial to find our imaginary roots. Okay, so when I graph it on my graphing calculator, I know I've got roots at -4 and -2. Now, because this is roots, I can leave the negative sign because this is not my factors, this is my roots, okay? And it's x minus the root. So when I do my synthetic division or synthetic substitution, okay, I'm going to show that the remainder is 0. So this gives me a -2. When I add, I get -20. Times this gives me, oops, what did I forget? I did it again. It's got a 0. There's no x cubed. I've got to put in that 0. And then my -18, and then my 12, and then my 80. Okay, so that gives me a -2. -2 times -2 is 4. -18 plus 4 is -14. Times -2 is 28. That adds up to 40. Times -2 is -80. So that means my remainder is 0. Okay. Now, because I've got another root, I'm just going to do a double synthetic division and put my -4 over here because I'm going to use these numbers. Okay. Bring down the 1. That gives me -6 times -4 is +24, which gives me 10 times -4 is -40. Yes, my remainder is 0. My depressed polynomial is x squared minus 6x plus 10. Okay, now when I go when I go to find my zeros, I already know that those are going to be imaginary numbers. They're going to be complex numbers. Okay? How do I know that? Because I already found the real ones. Okay? So my zeros, and how I'm going to do this, it's real simple. I'm going to use my quadratic formula. -6 squared minus 4 times 1 times 10. That gives me 36 minus 40, which equals -4. And then my quadratic formula, opposite of b, so it's 6 plus or minus the square root of -4 all over 2. Okay? This is going to simplify to 2i, so I can divide out that 2, and my other zeros are at 3 plus or minus I. Okay? So I've got zeros at -4, -2, 3 plus I, and 3 minus I. All right, let's try the guided practice. Okay, like I said, I've set it up, and I looked at my graphing calculator. I've got a real root at -2. Now, this is a 3rd degree, so I've got to have 3 roots. So I know that there are 2 imaginary roots. Got to find my depressed polynomial. All right, that gives me a 0. 0 here. 9 times -2 is -18. Okay, so my depressed polynomial is x squared plus 9. So to find my roots, okay, set it equal to 0 and factor it. Well, we don't want to factor it. So x squared equals -9. So x equals plus or minus square root of -9, which is plus or minus 3i. So I've got roots at -2, 3i, and -3i. Okay. Now, the complex conjugates theorem, and this is just kind of, remember from chapter 4, we used complex conjugates to rationalize denominators. Okay? Conjugates uses this idea of difference of squares. That if I have x plus y times x minus y, I'm going to get x squared minus y squared. We use it to rationalize denominators because sometimes we've got to get rid of radicals and imaginary numbers in the denominator. I can't have radicals or imaginary numbers in the denominator. So that's why I use conjugates. Okay? Now, conjugates are really, this theorem states that if a plus bi, now that's an imaginary number, is a 0, then so is a minus bi. Because you can't have a polynomial with integer coefficients and imaginary numbers. Okay? So in the example with the key concept, it said, so if 3 plus 4i is a 0 of this polynomial, then so is 3 minus 4i. Okay? Now, I went through and proved it. Using my graphing calculator, I found that it has a real root at -2. So I divided that out, got my depressed polynomial, okay? Used my quadratic formula, and there I got 3 plus 4i and 3 minus 4i, okay? So to write a polynomial, this is what the example says. If I'm given zeros at -1 and 5 minus i, that means I know there's also a 5 plus i. Okay, remember that factors, we write them as x minus r. Okay, so minus a -1 becomes +1. And then I've got to write these complicated things, okay, which is just, you know, I'm putting this in x minus this, and then I'm going to simplify. So I've got to distribute that negative, which gives me x minus 5 plus i, and x minus 5 minus i. Now, the reason I want to do that, and the reason I've kind of put parentheses around this x minus 5, is because remember when we had to write a quadratic, and we would change something and then we put a u in instead so we could factor it easier? I'm going to just use this chunk like an x. So I've got this plus I and this minus I, so that's going to give me a difference of squares, where I'm going to have x minus 5 quantity squared minus I squared, okay? And my other factor is x plus 1. So when I square this, okay, and I'm going to run out of room. When I square this, I get x squared minus this times 2 minus 10x plus 25. Now, remember, I squared is -1. So minus -1 is +1. Okay? Did I give myself some space? Nope. All right, I'm going to come over here in the margin. So this becomes x squared minus 10x plus 26, which doesn't factor nice. Okay, you should know that. And then I'm going to write my polynomial. I still have to multiply by this. I've got more room over here. So when I multiply by x, I get x cubed minus 10x squared plus 26x. When I multiply by 1, I get x squared minus 10x plus 26. Add it together, I get x cubed minus 9x squared plus 16x plus 26. That is my polynomial. 3 roots, third power, works. Okay. So, guided practice 4. So if the zeros include -1 and 1 plus 2i, I know there's also a 1 minus 2i. Okay, so writing my polynomial, I'm going to have x minus -1, which is +1. And I'm going to have x plus x minus, sorry, but they're both x minuses, x minus 1 plus 2i And I'm going to have x minus 1 minus 2i. Okay, so I'm going to simplify. And all I'm doing when I simplify is I'm just distributing that negative so I can get rid of these inner parentheses. X minus 1 minus 2i. And then I'm going to have x minus 1 plus 2i. And now I'm going to chunk this together so that it works like an x. And that gives me my first factor stays the same throughout all of this. And then I'm going to have x minus 1 quantity squared minus 2i quantity squared. Okay, and then I've got to simplify inside. Now you know that 2i quantity squared is going to be negative 4. Okay, because 2 squared is 4, I squared is negative 1. And so that's going to give me x squared, this times this doubled, minus 2x plus 1 plus 4. Okay, and x plus 1. So do a little simplifying, x plus 1 times x squared minus 2x plus 5. Okay. And then I'm going to do my distributive property, so I'm going to multiply by x. That gives me x cubed minus 2x squared plus 5x, multiply by 1. That gives me x squared minus 2x plus 5. And I get my polynomial. Okay. Hope this helps, and they probably put f of x in front. Third degree polynomial because I knew 2 roots, had to have a third. Okay, so that's your least degree. Hope that helps. Bye.